Hi, I'm Haiyue Yuan. I'm presenting the paper CogTool+, Modeling Human Performance at Large Scale. This work is jointly done with Shujun from University of Kent and Patrice Rusconi from University of Messina. Researches have been conducted to study human performance of human users interact with computer-based systems, which involves study human cognitive process, model user interface, and model human behaviors. Cognitive models are often used to facilitate the process. Among all, GOMS, KOM, and their variants have been proved to be effective and useful. Based on those cognitive models, psychologists and computer scientists work together to develop a number of cognitive modeling tools, and they have been widely used in both academy and industry. As you may already notice, CogTool+ is in the title of the paper. Therefore, we want to briefly introduce CogTool to the audience who are less exposed to the cognitive modeling. CogTool is developed at CMU and it's an open-source cognitive modeling tool based on KOM. The usage of CogTool consists of model user interface, model user interaction, translating high-level description into a low-level actor-based model, and human performance prediction. Despite the usefulness and popularity, similar to other cognitive modeling tools, there are some challenges. Challenges are raised when it comes to model system with dynamic tasks. One task is to model dynamic UI, and another task is to model dynamic user interaction. In addition, another challenge is to conduct large-scale modeling tasks, which normally require lots of manual work and it's time-consuming. We summarize the following as the major challenges, as well as the motivation to scale and extend CogTool's capabilities. The first one is to conduct large-scale modeling tasks automatically. For instance, consider an example of modeling 6-digit pin entry task, which will require producing up to 1 million models to cover all pins. The second one is to dynamically update and change default values of cognitive modeling operators and parameters such as those related to Fitts law. A third challenge is to build mixed probability model through simple steps. For instance, ability to model systems that involves left-hand and right-hand users and mouse touch-based interaction with respective weights or probabilities all together at the same time. Having all the challenges in mind, we develop a new cognitive modeling software framework, CogTool+. It consists of 4 main components: model generator, model interpreter, model simulator, and offline analyzer. The model generator generates simulation model and the meta model. The simulation model is used to define simulation settings and parameters. One meta model consists of a descriptive model and an algorithm model, where the descriptive model is for high-level user interface and the user interaction description, and the algorithm models are plug-and-play components written in JavaScript or CSV to support parameterization and automation. The model interpreter consists of a number of interpreter brokers, which can translate high-level description to low-level UI description and atomic-level user interaction scripts, and eventually output intermediate cognitive models. Including a scheduler, converter, and simulator, the model simulator converts intermediate cognitive models to a series of actor-based models and produces simulation results saved in CSV format. Finally, the offline analyzer takes the simulation results and post-processes data, followed by streaming the final output to an interactive visualization platform. Moreover, we would like to address another important feature of this framework. That is to allow software to work with external data to guide and help modeling and simulation. The framework allows users to link external data generated by either an algorithm model or direct input. I can give you one example here. Human behavioral patterns extracted from eye tracking data could be programmed as reusable behavior templates to run with CogTool+ to facilitate cognitive modeling tasks. Now, let's take an example to see CogTool+ in action. So the task is to model 50 6-digit pin entrance. Why? Pins remain as one of the most widely used user-authentication methods. Some cyber attacks rely on inter-keystroking timing dictionaries built from the user studies. We would like to demonstrate that CogTool+ is cost-effective and accurate for modeling 6-digit pin entrance at a really large scale. What are we modeling? First step is to link 50 pins saved in an external file. Then for each pin, we need to model the user interaction of pressing 6 digits, followed by pressing the Enter key. Next part is to determine if all pins have been modeled. If not, The program will assign another pin to model. Let's look at how the simulation model is used for this modeling task. A simulation model is written in XML. First task is to define the number of simulations, which is 50. Next, as illustrated here, we create a global array list variable with ID of external pin to link with the external CSV file. Then we will take a look at how the meta model is used to model the UI and user interaction. A descriptive model is also written in XML. It can link with the global variable defined in the simulation model, and it is also responsible for model the high-level user interface and high-level user interactions. Here is the representation of the modeling process. Now we have done the most important part and labor-intensive part to define simulation and meta model. Then the CogTool+ model interpreter, model simulator, and offline analyzer will take care of everything else. Let's take a look at the results. In this evaluation experiment, we compare the human data with simulated data produced by CogTool+. As illustrated in this figure, the correlation coefficients for the select pins are all close to 1, and the mean and standard deviation of correlation coefficient for all pins suggesting a strong association between the human timing data and the simulated timing data. Now we have shown the capability and the scalability of CogTool+ to some extent. However, it does not clearly demonstrate the use of algorithmic models to model dynamic UI and user interaction in more depth. We also did another evaluation work to model complex observer-resistant password systems undercover. Here, we just give you a quick glance of how the CogTool+ can model in these dynamic tasks. We can develop different JavaScript functions to be compiled using the model interpreter at the runtime to deal with the dynamic interaction involved in this system. In addition, we converted some visual search patterns as illustrated in these two videos into JavaScript-based behavior templates to facilitate the modeling task. More details can be found in our paper. To conclude, we would like to address that CogTool+ can allow the integration of external data, supports parameterization and automation, supports algorithm components, and a mixed probability model. By having these features, CogTool+ is compatible with CogTool and can produce valuable simulated data with less effort. Last but not least, it provides an alternative approach for large-scale modeling. We would like to see this warm contribution to the CogTool research community. Finally, we welcome you to visit the GitHub repository to give it a try. Thank you very much for your time. We would like to hear your feedback, comments, and questions.